Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be working on question 17 from the coverage of grade 12 elite. So question 17 says, consider the function f given by f of x equals x times e to the power of minus x squared. There are three parts to answer. Part A: at what value of x does the function attain its absolute maximum? Justify your answer. So to find where the function has the absolute maximum or absolute minimum, you need to find the critical points first. So we will differentiate the function, we will set it equal to 0, and then we will find the points, the critical points. So if you look back at the function, it's a product of two things. So let's name the first function, which is x. Let's name it first. And the exponential, we will name it the second one. So differentiating this function is done by applying the product rule. So to apply the product rule, you need to differentiate the first, leave the second, plus leave the first, differentiate the second. So differentiating the first will be 1, and then we will leave the second, right? Plus leave the first, and then differentiate the second. The derivative of e raised to negative x squared is minus 2x times e to the power of minus x squared. So this is the derivative of f of x. Now let's rearrange it, let's rewrite it. F prime of x will equal to e to the power of minus x squared minus 2, x times x is x squared, times e to the power of minus x squared. To find the critical points, set the derivative equals 0, and then find the value or the values of x. Notice that we have the exponential in common, right? So we can factor it out. So f prime of x will equal to e to the power of minus x squared times 1 minus 2x squared equals to 0. I just factored out e to the power of minus x squared. Now when the product of two things equals 0, that means the first one is 0 or the second one is 0. However, this one is never 0. That means this one is 0, which is 1 minus 2x squared equals 0. Get this to the other side. You get 1 equals 2x squared. Divide by 2 on both sides. So x squared equals 1 over 2. If you take the square root of both sides, so that's going to be plus and minus root of 1 over root of 2, which is a plus and minus 1 over square root of 2. So these are the critical points, plus and minus 1 over square root of 2. Now after finding the critical points, you need to place them on the number line. Okay, so let's place them on the number line. This is negative 1 over square root of 2, and this is 1 over square root of 2. Now we need to check the sign of f prime of x. We need to check the sign of the derivative to see where the function is increasing and decreasing. So if we select random points in between negative 1 over root of 2 and 1 over root of 2, such as 0, plug the 0 into the derivative, you will get positive. And if you select a value smaller than negative 1 over root of 2 or bigger than 1 over root of 2, you will get negative. So negative means decreasing, positive means increasing, negative means decreasing. So notice that at this point here, at this x value, we have a maximum. Increasing and decreasing, we call it maximum. And as long as it's the only maximum point, we can name it absolute or a global maximum. So we can say that we can write that f of x has an absolute maximum at x equals 1 over root of 2. That would be the final answer for part A. Okay, so moving to part B, this is find the antiderivative of f, and antiderivative means integral. So here for part B, we need to find the integral of x times e to the power of minus x squared dx. Now, notice that we cannot apply the power rule of integration, we cannot apply integration by parts or long division or completing the square. If you look at the exponential, we have an inner and outer, and this is a good sign for us to use u substitution. So let's assume that u equals minus x squared and du equals minus 2x dx. Isolate dx by dividing both sides by minus 2x. So dx will equal to du over minus 2x. You will use this piece and we will use also this piece. So we have two pieces of information, we can substitute them into our integral. Going back to the integral, we have the integral of x times e to the power of u. Instead of dx, we can write du over minus 2x. If you look at x, it will get cancelled, and there is 1 over negative 2, we can write it in front. So this is negative 1 over 2, I'm referring to this negative 2 under the du. So this is times the integral of e to the power of u du. Now we can simply say that the integral of e to the power of u is e to the power of u. So it's negative half e to the power of u plus c. And this is negative half e. Now substitute minus x squared back, and then plus c. That would be the answer for part B. We used u substitution. Now, I copied part C here so that I get enough space. It says find the value of the integral from 0 to infinity of x f of x dx, given the fact that the integral from 0 to infinity of e to the power of minus x squared dx is equal to square root of pi over 2. Okay, now first of all, this is an improper integral because one of the boundaries of the integral is infinity. So we can replace it with a variable and use the limit here. So we can say this is the limit as t approaches infinity of the integral from 0 to t x. Now f of x is given on top. It's x times e to the power of minus x squared dx. I'm just substituting what f of x is here, okay? So we will start doing the integral, and at the end we evaluate the limit. Okay, so leave the limit untouched until the end. Now, if you look at this type of integral, we cannot use u substitution here because x will not get cancelled. So we can use integration by parts here. Integration by parts is done using u, du, dv, and then v. So we will let u equals x, and du will be 1 or 1 dx, okay? But it's 1 dx. And dv will be x times e to the power of minus x squared. And what's the integral of this expression يعني to go from dv to v you need to integrate, but we did it in part 2. So if you look back at part 2, we did it. It's negative half times e to the power of minus x squared. So we already did it before. So now we can multiply and then minus the integral. So you can use this setup for this question. So going back to the question, we have the limit, keep it in front as t approaches infinity. Now this integral we can replace it with x times negative half e to the power of minus x squared, right? I'm just multiplying the u and v, minus the integral of 1 over 2 or negative 1 over 2 e to the power of minus x squared dx. And because I am using integral here, I should keep the 0 and infinity, okay? The 0 and infinity, or 0 to t. But to use the fact given in the question, let's keep it 0 to infinity. Now let's just rewrite it, rearrange it. So we have the limit. Okay, so we are forgetting something. We evaluated we did the integral in the first part. So here we can say this is evaluated from t equals 0 or x not t. This is evaluated from 0 to t. This is evaluated from 0 to t. So the limit as t approaches infinity of, now if you plug in the t you will get, but let's rearrange it first, negative half in front times t times e to the power of minus t squared, okay, minus, if you substitute the 0 everything will be 0, okay, and then there is here there is minus and there is minus, we can write it as plus, and this 1 over 2 just put it outside the integral in front, times the integral from 0 to infinity of e to the power of minus x squared dx. Okay, so this integral here is given. This integral is given here. So we can replace it with square root of pi over 2. And we can evaluate the limit at the same time. Now, what happens if you plug in infinity in this expression? Now you will get negative 1 over 2 times infinity over, or times 1 over e to the power of infinity squared. Now this is here, the power is negative, okay? If you write it down, the power will be positive, okay? Plus, this is 1 over 2, and the value of this integral is square root of pi over 2. Now, if you look at the first term here, it's going to be 0, because e to the power of infinity squared is much stronger than infinity itself, and it's written in the denominator, so something over something really big, it will be 0. So this is 0 plus 1 over 2 times square root of pi over 2. This is equal to square root of pi over 4. And that would be the final answer. I hope that was clear. This is all for part C. Good luck and see you in the next video.